Welcome to this educational presentation brought to you by CAMX. In this joint session brought to you by Plataine and Virtek, we'll be discussing the advancements in composites manufacturing, how smart technologies can push forward manufacturing efficiencies while reducing costs. In this presentation, we'll cover the implementation of industrial IoT and AI in composites manufacturing, accompanied with concrete use cases and the savings and ROI behind these technologies. My name is Clay Bullock. I'm Vice President of Plataine for North America, and I have with me today Vincent Tran. Vincent?
Thanks, Clay. My name is Vincent Tran, and I'm a product manager at Virtek. Thank you to our partners at Plataine as well as CAMX for providing us the opportunity to speak with you today.
Thank you, Vincent. Industry 4.0 technologies bring an enormous opportunity to improve factories in various areas such as productivity, agility, and customization, controlling the lot size. As McKinsey is our partner for the Industry 4.0 practice, I can share this data with you. In these uncertain times, cost reduction, inventory reduction, and manufacturing agility have become even more important. The pandemic has changed many things, and today's manufacturers cope with different challenges. We've had numerous discussions recently with industry leaders, and this is what we hear from the field. Canceled orders and reduced demand in some industries, supply chain disruptions, shortages in raw material and parts or component supply, increases in costs related to raw material and logistics, limited availability of some of the workforce and other resources, and government instructions and restrictions that change frequently. Companies today are in the search for quick fixes and smart tools that can help them handle today's challenges and survive these rough times. Optimization software that leads to cost savings is a very important tool. Also, improved visibility and production control are on the minds of all manufacturers. The migration from legacy business applications to the cloud creates new opportunities. A new generation of software and applications have emerged to take advantage of innovation accelerators like artificial intelligence, machine learning, IoT, and advanced analytics. This survey from IDC shows that companies continue to invest in technology in order to cope with the uncertainties during these challenging times. So the first step in the process toward a smart composites factory would be to gather the relevant data that is required for optimization. We identified three main categories: legacy systems such as ERP, MES, etc., sensors and machines on the production floor, and third, staff input and reporting that must be digital, apps as opposed to paper, which is useless in the digital era. Step two in the process is storing the data gathered and analyzing it. The Plataine software, for example, is comprised of three tiers, as you can see. On the bottom, there's the digital context layer where information is gathered. Above that, we build the knowledge layer that allows us to offer alerts and predictive analytics. And the third layer allows the software to offer recommendations and optimization. Here's an example from our day-to-day life. The first layer holds information about your factory inventory of material in the freezer and other storage areas. The second layer will identify that a pre-preg roll is about to expire and sends an alert to the freezer manager. The third layer will assign this material to the appropriate job so that material is used on time, eliminating the chance to scrap it. Plataine and Virtek offer complete factory traceability and material shelf life management. This ensures material shelf life is automatically managed by a software from the freezer to the autoclave, allowing staff to focus on production. Supplies that are being laid up in the clean room are automatically reported, and all production history records, what we call the digital thread, is recorded in the cloud and can be used later for inquiries and audit. Let's discuss our first use case around material assignment. With thousands of material rolls in various freezers and storage areas, it is impossible to track all inventory manually or using Excel. The advantage of using a software that all inventory records are up to date, and it guides users to make an optimized selection, taking into account shelf life parameters, material length, and many more considerations. This example proves that significant material savings and efficiency could be achieved using advanced software. While FIFO and other good practices could take you that far, new software tools could further improve your operations. In my next example, the software identifies a late work order and projects that a material expiration problem might occur if not handled correctly. The software alerts the user at the cut and kit station so he can address the problem and prevent potential production delays. The next use case is around layup operations. In some cases, our customers report using the wrong tool for layup, which results in wasted time, material, labor, and delays. Before starting the layup process, the Plataine software provides the layup operator with a confirmation that the right kit and layup mold are used for the job. Maintaining all equipment and tools in a timely manner is critical to any operation. It is quite tricky to manage thousands of tools and machines, since usage of under-maintained tools leads to defects, while over-maintenance is expensive and slows down production. In this industry survey by Deloitte, you can see that a reactive approach can get you to 50% equipment efficiency. If you wish to increase that and save money on excessive equipment and tools, you have to track your tools and use a software for proactive and predictive maintenance. This is where sensors and IoT can help track equipment duty cycles and predict machine or tool reliability. In this example, we used RFID tags to track tools' whereabouts and autoclave duty cycles. We use tags that are resistant to high temperatures and pressure. The software provided complete visibility over clean rooms, staging areas, curing area, and demolding. The outcome was reduced delays due to missing tools, increased tool availability, avoiding unplanned tool maintenance. And now I'll hand the mic over to Vincent.
Thank you, Clay. The next few slides will cover the use case pertaining to the usage of laser projection in particular during the composite layup process, and combines the use cases that Clay previously described. Laser projection is a technology that's commonly used for the production of composite parts to project things of all ranges and sizes and complexity. For those of you who may not be familiar, laser projection replaces the need for manual measurement or physical templates by projecting outlines onto the tool surface, helping to guide the operator into the positioning of plies and other materials during the layup. It also helps to digitize the processes by shifting your paper-based information onto the screen and making that data more easily accessible to the operator. You can see from the image on the left, as well as the video playing on the right, the laser clearly projecting onto the tool surface, where the operator simply needs to align the ply to the projection. So by taking the measurement out of the process, as well as the reliance on prints and other instructional references, it significantly reduces the skill level of the operator, allowing them to focus on the layout task at hand. It also helps to greatly improve the quality of your parts with higher accuracy and greater repeatability across several builds. This obviously leads to reduced rework and avoided costs further down the line. The benefits of laser projection are fairly well understood in the composite industry. So how about combining its strengths with the promise of industrial IoT? What kind of benefits can be realized with such an approach? We can go over what makes a laser projection system, which can be a critical human input, a valuable data point to extract critical information. First of all, in order to collect data for more of your processes in production, it helps to have a laser projection system that's flexible and capable of performing various jobs. This means the system should be easy to use, align and project with relative quickness and ease, and in a form factor that lends itself to being used in various applications. This becomes important because by bringing laser projection solutions to be applied to various manufacturing processes, those processes become digitized and enables the collection of the additional production data. This data could include information pertaining to the operators who are logged in and working on particular processes. You also would have access to which plies are being laid up and how much progress has been made on an individual work order. And with a laser projection system, you can enforce a strict sequence and build order of which that information can also be extracted. So enabling industrial IoT on a manufacturing system, like a laser projection system, can help give you access to this information, providing valuable insights regarding all your processes. What benefits can be realized by combining the flexibility of a laser projection system and the power of industrial IoT? Combining IoT with laser projection helps to provide valuable metrics that can help inform you of your processes and enhance the ROI of your equipment investments. This is accomplished by providing you with more detail related to the tracking of the progress of your production parts, which can give your supervisors a bird's eye view of what's happening on the manufacturing floor, all from a central point of information with increased visibility. It can also help to ensure that the right materials are being assigned to the right job, as it can tell exactly which plies are being worked on in real time. As Clay described in the use case number 4, all the information being collected about the production of your parts over time can also help determine when your tools need to be maintained proactively and predictively to help avoid those quality costs you may not discover until it becomes much too late. And with all that data, that leads into a level of quality prediction that can be performed by an AI, taking into consideration factors such as material life, tool wear, production time, to help guide operators and supervisors alike to make more intelligent decisions and assist in the improvement of all your processes over time. So when selecting a manufacturing system, like a Virtek laser projection, to implement for your processes, not only is it important to identify one that's capable of an IoT integration, such as that with Plataine, it's also important that this system is flexible and capable of supporting all your layup processes to enable the power of IoT across your entire manufacturing floor. At this point, I'd like to pass it back to Clay for him to summarize today's presentation.
Thank you, Vincent. In summary, we'd like to point out that AI and Industry 4.0 address significant business pains. Digitalization and factory visibility is now more critical than ever. Implementation focus must be on cutting costs and coping with today's uncertainties. Quantifying the benefits is within reach and demonstrates significant outcomes. We'd like to thank you for watching this joint presentation between Plataine and Virtek, and thank CAMX for the opportunity to present it to you.
For more information, you can contact either of us, Clay of Plataine and Vincent Tran here at Virtek for additional information about either platform. Thank you for your time.